In this video, we're going to look at independent versus not independent or dependent events. So first we have to determine whether events are independent or not. Two events are independent events when the occurrence of one event does not affect the occurrence of another event. So for example, flipping a coin, flipping it twice, when you flip it one, the action's done, you flip it again, it's a completely separate action. So it doesn't depend on each other. So those are independent events. Two events A and B are independent events if and only if the probability that both events occur is the product of the probabilities of those events. So the probability that both of those events occur is each of their separate probabilities multiplied together. So a lot of this stuff you can figure out without doing the formal checking of the probabilities. Just check to see if one depends on the other one. So a student taking a quiz randomly guesses the answers to 4 true or false questions. It says that you can use a sample space to determine whether guessing the correct answer to question 1 and guessing the correct answer to question 2 are independent events. We're not going to do that. We're just going to think about this. If there are 4 true or false questions, those are completely separate questions. Question 1 doesn't depend, question 2 doesn't depend on question 1. They're completely separate entities. So we don't even need to use anything mathematical here. We can just use our brains to recognize those events should be independent. Those questions are separate from each other. They're true or false. So they're going to be independent. They don't depend on each other. A group of 4 students includes 1 boy and 3 girls. The teacher randomly selects one of the students to be the speaker and a different student to be the recorder. Use a sample space to determine whether randomly selecting a girl first and randomly selecting a girl second are independent events. So in this case, if we think about what's happening, right, 4 students. So if you pick 1, you now only have 3 students to choose from. So your next selection, dependent on who you picked first, you can't pick the same student twice. So if you already picked them first, there's no way you can pick them as the second choice. And so in that case, these ones are not independent. These are going to be dependent events. So we can also determine this using conditional probabilities. When 2 events A and B are independent, the conditional probability of A given B is equal to the probability of A, and the conditional probability of B given A is equal to the probability of B. Since they don't depend on each other, that first condition being met doesn't affect the second thing that we want at all. So that's why it's just the original probability of the thing that we want to happen. So let's actually apply this. In example 1, it makes sense that the events are independent because the second guess should not be affected by the first guess. In example 2, however, the selection of the second person depends on the selection of the first person because the same person cannot be selected twice. These events are dependent. 2 events are dependent events when the occurrence of one event does not affect the occurrence of the other event. So we have the probability of dependent events. If 2 events A and B are dependent events, then the probability that both events occur is the product of the probability of the first event and the conditional probability of the second event, given that the first event occurs. So this is different from our independent events. Independent, where the probability of A and B, lower cases there, A and B, we said was their individual probabilities multiplied together. So you first need to determine whether your events are independent or dependent, and then you use one of these 2 rules to find your probability. A spinner is divided into 5 equal parts. Find the probability that you get a 5 on your first spin and a number greater than 3 on your second spin. So if we think about spinning a spinner, and if I spin it once, spinning it again is a completely different action. It doesn't matter what I got on spin 1. These events are going to be independent. So these are independent events. Independent. So I know I'm going to use the rule here for independent events. So the probability that both of these things happen is going to be the probability of their individual things happening, and that's the product. So first, the probability that you get a 5 on your first spin. So since all of these parts are equal, I see that 5 takes up just 1 space and that there are 8 total spaces. So that probability should be 1 out of 8 times The second probability, so a number greater than 3 on our spin. So a number greater than 3 would be 4, 5, 6, 7, and 8. So that's 1, 2, 3, 4, 5 of our 8 spinners there. So that product would be 5 out of 64. So that should be our probability. Here we've got a bag that contains 21 dollar bills and 5 $10 bills. You randomly draw a bill from the bag, set it aside, and then randomly draw another bill from the bag. Find the probability that both events A and B will occur. There's 3 words here that are going to dictate whether these are independent or dependent, and it's the words set it aside. So we're drawing something from the group, we're setting it aside, which means our original group has less things in it, which means our second event is going to depend on the first event. We can't draw the same thing twice. If it's already out of the choices, it's gone, it's dependent, right? Okay, so let's look at event first. Let's go back to our rule. So our rule up here, oops, come on, scroll please, there we go. Says we're going to take the probability of the first event. So probability that the first is 10 times the probability that the second, probability that the second bill is a 10 as well, given that we drew a 10 first. So those are the probabilities that we need. So the probability that the $10 bill is drawn first, the first bill is $10. How many $10 bills do we have? We've got 5 of those. And we have to divide that by how many total bills there are. So 20 and 5 would be 25 total bills. Okay, so next we need the probability that we drew a $10 bill second, given that we drew a $10 bill first. So after we've drawn a $10 bill already, this changes to being $21 bills, but now we only have 4 $10 bills. Since one was already drawn, we have one less $10 bill to choose from. So using that new information, how many $10 bills do I have left? I've got 4 of them left. Out of how many total bills? 20 and 4 would be 24 total bills. 5 times 4 gets me 20. 25 times 24 is going to be 600. And if we want to, we can reduce that to 1/30 for our probability.